Welcome to Tesla Car World. Today we have a piece of content that is both humorous, centered around Tesla and Elon Musk, and at the same time quite serious, because a great deal of money is being wagered on whether this effort will ultimately succeed. Therefore, we need to clarify the situation quickly before things go too far and spiral beyond control. Now let's take a closer look at what exactly happened. Recently, many of us have likely come across a newly surfaced video from a Tesla Optimus Bot demonstration in Miami, showing Tesla's humanoid robot falling hard, collapsing backward onto the ground. However, what raised suspicion wasn't the fall itself, but the specific hand movements the robot made as it went down. These motions strongly suggest that the robot was mimicking a remotely controlled operator who was panicking and removing a virtual reality headset. When watching the video, this appears quite evident. This revelation caused significant disappointment among users. We can fully accept that a robot may fall, perhaps many times, during the research and development process. What is far less acceptable, however, is the fact that Elon Musk and Tesla had previously presented the robot as being fully autonomous, while the actions seen here clearly suggest the opposite. Scientific progress not keeping pace with expectations is understandable, but what users are struggling with most is the growing sense of having been misled. Humanoid robots are currently at the center of attention. Billions of dollars in investment are pouring into this field, not just Tesla, but into many other companies as well. Elon Musk has stated that Optimus will become a trillion-dollar product for Tesla.
So the scale of Optimus, like I said, that's really going to be something else. I think it's going to be the biggest product of all time.
At present, humanoid robots are able to use new forms of artificial general intelligence to replace humans in an increasing number of jobs. However, there remain many serious concerns surrounding this effort, both ethically and technologically. From an ethical perspective, many people are uneasy when Elon Musk speaks of a robot army that he intends to deploy. From another angle, there is widespread anxiety that robots will take away human jobs in the not-too-distant future. This raises a crucial question. Will robots cause people to lose their jobs and fall into poverty, or will they instead help eliminate poverty, as Elon Musk has previously suggested? From a technological standpoint, most humanoid robot demonstrations to date have relied on remote human control, indicating that there is still a significant gap between software and hardware. This is entirely understandable, as achieving meaningful technical breakthroughs requires a great deal of time and research. This can be seen in other humanoid robots as well, such as Figure AI or Boston Dynamics. Elon Musk believes that Optimus Gen 3 will spark a humanoid robot revolution, not because it is stronger or faster than other robots, but because it addresses the fundamental problems that the entire humanoid robotics industry has been stuck on. Cooking and performing all household tasks represent the most demanding test, and one that cannot be faked. First, it is important to clarify a key point. The yellow and black Tesla bot images with upgraded arms that we have seen recently are not Optimus Gen 3. Elon Musk himself has clearly confirmed that Tesla has not yet revealed Optimus Fib 3, and those images only depict version 2.5 and remotely operated units used solely for testing purposes. This distinction is crucial because under the current plan, Optimus Gen 3 is expected to launch in January, and this will no longer be an experimental prototype. It will be the first fully realized version, refined and polished to operate in the real world. While Optimus Gen 2 relied on remote control and even suffered falls during testing, Tesla Bot Gen 3 is designed to be fully autonomous. Elon Musk has stated that Optimus Gen 3 can perform up to 3,500 unlimited tasks per day, thanks to its ability to learn from and imitate human behavior. He even believes the robot could cook daily meals and prepare breakfast, functioning as a true household assistant. This is not emotional marketing, but rather a strategic claim that reflects Tesla's long-term ambitions. So how will Tesla Bot Gen 3 overcome the challenge of becoming a household caretaker? And why was Elon Musk genuinely astonished by Optimus's cleaning behavior? This will be the final, fully finished version that allows Optimus to complete up to 3,500 open-ended tasks per day, thanks to its self-learning and imitation capabilities. Elon Musk is confident that it can cook daily meals, clean the house, or even prepare breakfast like a real household assistant. In a recent earnings call, Elon Musk revealed that Tesla Bot 3 is expected to launch in early 2026 with an extraordinary design optimized for mass production. It is truly impressive. Currently, Optimus 5 2.5 features several notable visual improvements over the previous version. The exterior has been redesigned with smoother lines, more neatly covered joints, and far fewer exposed cables. The design language has shifted from a boxy form to a more rounded and softer shape, giving it a friendlier appearance and making it look more like a finished product rather than an experimental prototype. Beyond design changes, Optimus 5 2.5 is now integrated with xAI's Grok voice assistant. Optimus can respond to questions verbally, although its responses are not particularly fast and there is still some noticeable latency. While its answers may sound slightly hesitant and awkward, we believe this still represents a significant step forward compared to earlier versions. However, few people realize that Tesla is actually focusing on finalizing Optimus Gen 3, which is expected to debut later this year. This version comes with upgrades that could take Unitree G1 several more years to catch up to. Optimus Gen 3 will concentrate on expanding the range of useful tasks it can perform, most notably impressive household capabilities, including cooking and cleaning, far surpassing the current version. Even more impressive, Optimus will feature an upgraded battery life, just 2 hours of charging for up to 22 hours of continuous operation. Of course, its price will no longer be $20,000. To enable Optimus to cook or perform other useful tasks, Tesla has invested tremendous effort into the robot's true brain and its arms. Elon Musk recently admitted on X that one of the biggest challenges is building a dexterous hand, and mass-producing thousands, or even millions of these hands is 100 times harder. Musk acknowledged that building Optimus is harder than the Model X, harder than the Cybertruck, and even harder than building a gigafactory, though still easier than Starship. According to Elon Musk, humans evolved into their current form and function, and everything in the world, from objects and tools to living environments, has been designed for human use. Therefore, if a robot is meant to do everything a human can do, it also needs a human-like form, especially hands, which are the tools that allow us to build the world. Musk has repeatedly emphasized that the human hand is a marvel of evolution, with more than 27 degrees of freedom and a tendon-driven control system powered by forearm muscles, much like a puppet mechanism, both powerful and precise. Thanks to our hands, humans can swing a baseball bat, thread a needle, play the piano, or assemble and disassemble a car. No other part of the body comes close in terms of versatility. If we want to create a truly general-purpose robot, the hand problem must be solved first. And as Musk has pointed out, this is exactly where most other robotics companies fail. They can build machines that walk, run, jump, box, or even play table tennis, but they still cannot create a hand capable of peeling an orange or washing vegetables under running water. These machines fail to meet the tasks people actually want robots to perform. We believe the easiest way to visualize Optimus's potential is to place it in a kitchen. Cooking is not just a sequence of basic motions, it is a comprehensive, real-world test for a humanoid robot. Even a simple meal like bacon and eggs requires the robot to open the refrigerator, recognize ingredients, pick up eggs without cracking them, turn on the stove, hold a pan, crack the eggs, add oil, stir evenly, and time everything precisely. Each step demands a seamless combination of dexterous hands, cognitive intelligence, and real-time action coordination. If Optimus can cook, it means it has truly crossed the threshold from an industrial robot into becoming a part of the human world. Which two key criteria is Tesla Bot Gen 3 prioritizing in its training? Elon Musk has been continuously unveiling new updates for his humanoid robot. He has even confirmed that Optimus will become Tesla's most valuable division, and that rival robots are missing at least 2 critical criteria needed to catch up with Tesla in this race. We believe that a new version of the Tesla Bot is about to launch, and Musk may be right, as he has revealed that a new design will be introduced by the end of this year. Musk has suggested that all 8 billion people on Earth could want 1 or even 2 Optimus robots, meaning the robot-to-human ratio could one day be equal to or even higher. Clearly, this sounds absurd and unrealistic, as many people remain skeptical about the real-world usefulness of humanoid robots, and many also believe Optimus is too expensive, even if Tesla can sell it for $20,000. Yes, we really like Optimus, but we must admit that Tesla still has a lot of technical work to do to convince customers to buy it. That's why toward the end of the year, Tesla showcased a wide range of updates, from bringing 43 humanoid robots to the We Robot event to demonstrate human interaction capabilities, to confirming voice and language upgrades for Optimus, followed by updates showing that Optimus can climb stairs, self-charge, and move fully autonomously, which is truly impressive. Let's talk a bit about Optimus's walking capabilities. In Tesla's latest updates, the robot has been seen walking around the 4,680 battery production facility at Gigafactory, Texas, selling popcorn at the Tesla diner, and even serving drinks at large, crowded events. Notably, Optimus now walks with greater confidence and can automatically avoid obstacles, interact with humans, hold conversations, and even joke like a friend. This is genuinely impressive because it means Optimus can autonomously navigate factory environments and adapt to a wide range of settings, such as indoor spaces, busy streets, or even crowded retail stores. If you look closely, you can see the objects that Optimus is identifying, similar to how Tesla vehicles perceive their surroundings and process situations that require intervention to avoid accidents. Most importantly, this mapping data can be stored and shared with other Optimus robots. This means that once one Optimus robot has explored and analyzed the terrain and mapped an area, other robots can recognize that same environment and move through it fluidly. The continuous collection of data makes them smarter over time, without Tesla needing to retrain each robot from scratch. That's right, this is no longer a sci-fi robot like those in movies such as I, Robot. With the goal of deploying thousands of Optimus robots in factories next year, along with a limited number sold to customers in 2026, Tesla is truly accelerating its humanoid robot ambitions. According to information shared by Sawyer Merritt, Tesla has been granted a new permit related to the Cortex 2 data center located within the Giga Texas complex, confirming that the facility can operate at an electrical capacity of up to 200 megawatts. This represents a major expansion of Tesla's infrastructure, specifically designed to directly support the training of the Optimus humanoid robot using advanced artificial intelligence models. With this level of power availability, Tesla is capable of performing large-scale machine learning workloads, significantly accelerating the pace of research, testing, and deployment of AI-driven autonomous robots across multiple sectors. This move demonstrates Tesla's growing ambition to establish itself as a key player in the AI data center domain, exerting substantial influence on the broader ecosystem of robotics, computational infrastructure, and industrial automation applications. Recent developments in Tesla's AI infrastructure investment strategy indicate that the company is aggressively expanding beyond its core electric vehicle business. The licensing approval for the Cortex 2 data center at Giga Texas marks an important milestone in Tesla's long-term vision for intelligent robotics. According to Sawyer Merritt's post dated December 17, 2025, the facility has been authorized to operate at a capacity of up to 200 megawatts, with a primary focus on training the Optimus humanoid robot. This clearly reflects Tesla's strategy of scaling its AI computing capabilities, building on the success of the Dojo supercomputer, originally developed to train autonomous driving models, and now extending its application into humanoid robotics. Within the broader technology landscape, the rapid proliferation of high-capacity AI-focused data centers is an inevitable trend, as breakthroughs in deep learning and neural networks increasingly demand massive computational resources. Reports from the International Energy Agency project that by 2030, AI workloads could account for approximately 8% of global electricity demand. The construction of Cortex 2 places Tesla firmly in alignment with this trend, while also positioning the company as a pioneer in transferring AI from purely digital environments into physical automation. The Optimus project, first unveiled in 2021, aims to develop a general-purpose humanoid robot capable of performing a wide range of tasks in factories, households, and hazardous environments. This ambition is supported by the vast volumes of real-world data collected from Tesla's global vehicle fleet. The timing of this new permit coincides with growing attention on AI-powered robotics, as many industry analysts forecast that the global humanoid robot market will expand from approximately USD 1.5 billion in 2023 to over USD 38 billion by 2035. By allocating such a large energy supply to Optimus training, Tesla is directly addressing core AI challenges such as real-time decision-making and adaptability in complex environments, critical requirements for commercializing humanoid robots. This not only strengthens Tesla's internal technological capabilities, but also signals that AI could become a major new revenue pillar alongside electric vehicles, potentially driving transformative change in industries such as manufacturing and logistics, which are currently facing significant labor shortages. From a business perspective, the Cortex 2 data center represents a strategic investment with the potential to unlock substantial opportunities in the AI robotics market. Concentrating Optimus training within a 200-megawatt infrastructure allows Tesla to shorten AI model iteration cycles, thereby accelerating the deployment of robots into real-world operational scenarios. This is particularly valuable in automation-intensive sectors such as automotive manufacturing, where Tesla already utilizes robots extensively. Optimus could help reduce operational costs by an estimated 20 to 30%, based on productivity improvements observed in comparable AI deployments, as reported by McKinsey in 2024. Market analyses suggest that if Tesla commercializes Optimus through direct sales or leasing models, it could tap into a highly lucrative opportunity, with the global service robot market projected to reach a potential value of $150 billion by 2030. In terms of competition, Tesla faces established players such as Boston Dynamics, renowned for its Atlas robot. However, Tesla's key advantage lies in its vertically integrated approach and in-house AI hardware development, which enables superior cost optimization and scalability. Additionally, Tesla could pursue strategic partnerships, for example, collaborating with American Logistics and Condian, Bedouin Moneritic Sinridi set to develop automated warehouse solutions. Nevertheless, regulatory challenges remain. U.S. energy authorities are increasingly scrutinizing the impact of large-scale data centers on power grids. Ethical considerations also pose challenges, particularly regarding the creation of diverse training datasets and ensuring safe human-robot interactions. For companies seeking to emulate Tesla's approach, monetization strategies could include subscription-based AI updates, similar to Tesla's software-driven revenue model for its autonomous driving features. Although the upfront investment for a facility like Cortex 2 may reach hundreds of millions of dollars, integrating renewable energy sources, such as solar power at Giga Texas, could significantly reduce environmental impact and long-term operational costs. From a technical standpoint, the 200-megawatt capacity of Cortex 2 is sufficient to power thousands of high-performance GPUs or Tesla's proprietary AI chips, which are essential for training complex neural networks that enable Optimus to perform perception, locomotion, and manipulation tasks. This scale is comparable to some of the world's leading AI data centers, where training large language models has historically consumed hundreds of megawatts of electricity. To operate efficiently, Tesla is likely to deploy advanced cooling solutions, such as liquid cooling, which has been proven to be significantly more energy efficient than traditional air-based systems. But in the end, who should be legally responsible if an AI-trained humanoid robot causes harm in a factory, warehouse, or home? The manufacturer, the software developer, or the end user? Please share your opinion in the comments section below this video. Thanks for watching our video. Subscribe now so you don't miss the next breaking Tesla update. It's coming in just 2 days. If you want to explore more exciting information about Tesla EV or Tesla Bot, don't forget to hit the like button and share this video. Also, make sure to turn on notifications so you never miss our latest videos. If Figure 03 runs like a basketball player, then Tesla Optimus could be said to run like a marathon athlete. Especially when you compare it to those Russian robots we've seen sliding and crashing to the ground just from trying to take a few basic steps. In just a few months, Optimus went from stumbling around like an old man losing his balance to a humanoid robot that can actually run and literally run at nearly 7 miles per hour, a speed no one would have dared expect Tesla to hit just a year ago. Even more surprising, look at each step, each rhythm, each landing. The moment when both feet leave the ground is truly unbelievable. It looks so realistically human it's hard to wrap your mind around. You could say we're just repeating an old story, but what really concerns us is, how does the Tesla Bot Optimus reaching 7 miles per hour benefit us in our lives? Compared to robots from 10 years ago, Figure 03 is downright insane, but we're still not sure how reliable or durable it really is. Of course, perspectives vary from person to person, but what we mean is this. Which robot runs more like a human isn't the most important thing right now, because a robot's priorities aren't the same as a human's. Power consumption and stability are the key factors. The best robot is the one that can cover the longest distance using the least amount of energy. What we need is something that can clean the house efficiently and wash dishes by hand. Who cares which one imitates humans better? What matters is which one washes the dishes better. Every time we look these robots up, we see them doing things that honestly make us uncomfortable. Kicking, doing flips, running, spinning in midair. Look at figure 03. Its upper body to leg proportions are completely off. Is that supposed to be some new human standard? Lowering the center of gravity like that is basically cheating. And that very approach is what keeps these robots from stepping out of the lab, even if they do have a price advantage at $20,000. On top of that, figure 03 may run better. But that has nothing to do with anything. We would never buy one. Why would we want a machine that can record all of our movements, upload geospatial data of the inside of our homes, and potentially attack or kill us? No thanks. Maybe Elon Musk's caution and focus on security with the Tesla bot Optimus will give us more peace of mind. Elon Musk has confirmed that he will sell the Tesla bot Gen 3 for $20,000 next year, and we believe him. Because right now, the issue isn't that Tesla is building robots, it's that they're manufacturing every part themselves and will be able to mass produce them using gigapress technology, which means costs will be far lower than any other company. Every other company has to import all their components from third parties, and after multiple rounds of price hikes, those robots will be completely unaffordable. Optimus will be affordable for everyday users, and its hand technology is unmatched. Elon has said that creating the Optimus hand, with that range of motion and that level of dexterity, was the hardest thing he's ever done, aside from Starship. Most viewers are focused on the scenes of Optimus working inside the Tesla factory, lifting heavy objects, moving inventory, inspecting the production line. But Musk is talking about something far more important. Optimus was created to become a homemaker, a permanent household assistant. That is the real vision. And when you put that statement into the context of what Optimus is already capable of, you start to see clearly that Tesla isn't trying to build a robot just to show off in a factory. Tesla wants to bring a robot into your home. When Optimus can fold laundry, wash dishes, organize belongings, help with cooking, carry heavy items, monitor the elderly and trigger emergency alerts, understand household habits, and learn from its environment to do its job better each day, then it's no longer a robot in the way we used to think of robots. It becomes a member of the family, a being that can remember, learn, adapt, and handle repetitive tasks without ever getting tired, complaining, or needing time off. This is the moment when the concept of a home robot from sci-fi movies begins to step into real life. When you see Optimus run like a human, grasp objects like a human, and map its environment like a human, you start to understand why Musk says Tesla isn't building a machine. Tesla is creating the general-purpose workforce of the future. Not a simple cleaning robot, not a wall-mounted mechanical arm, but a humanoid being capable of doing the everyday tasks humans do, from the simplest to the most complex. A labor force that can be mass-produced on an industrial line, upgraded continuously through software and work without ever getting tired. And once Optimus reaches the level of a true homemaker, its value will far surpass anything we've ever owned in our homes. A device that can care for children, assist with cooking, clean the house, bring items to elderly family members, check if the gas stove is off, and call emergency services when it detects a fall, all within a single machine. This is the biggest shift since the arrival of the smartphone. If the smartphone gave humans an extended mind, then Optimus will become the extended hands and feet of every household. What's interesting is that while the public is busy focusing on the footsteps, the hands, the 7 miles per hour running speed, there's a small but extremely important detail almost no one notices. Optimus's charging system is already complete. Optimus now has a stable, fixed, and fully optimized charging port designed for industrial environments. It sounds simple, but for a humanoid robot, this is a milestone that signals ready for production. When a robot can charge easily, reliably, quickly, and without needing its battery removed, that's when you know it was built to operate 24/7. If you want a legion of robots operating by the thousands at the same time, their charging system must be non-flammable, must not break cables, must not require human intervention, and must not interrupt the workflow. Robot companies often overlook this step, but Tesla doesn't. The fact that Optimus now has a fixed charging port proves they're no longer in the research phase. They're in the preparing for mass production phase. Because only when you standardize everything, from plugs, wiring, and power delivery to docking positions, can you deploy millions of robots the same way you deploy millions of Model 3s. If you look back at the evolution timeline, you'll see everything is progressing faster than any other tech sector. 2022. A robot on support cables, wobbling around like someone who looks completely unsteady, as the user jokingly described. 2023. Able to walk, hold light objects. 2024. Self-balancing, highly dexterous hands. 2025. Runs 6.8 miles per hour, 22 degree of freedom hands, preparing for Gen 3. From a robot that once wobbled and shook to one that runs like an athlete and grips objects like a human. All in just 3 years. No hardware field has ever accelerated this fast. Not phones, not computers, not drones, not EVS. Nothing comes close to the leap Optimus is making. And if Optimus continues to make a jump like this every 12 months, then in the next 2 to 3 years we could see a robot that can fully cook meals, clean a home without instructions, work 12 to 16 hours a day in factories, replace most simple manual labor, and even assist with basic medical care. Once robots reach the Homemaker threshold, the market will expand to hundreds of millions of households. At that point, Optimus won't just be a tech product. It will become the foundation of a new kind of society, one where humans are no longer forced to spend 30% of their lives doing housework or heavy manual labor. Imagine a future where you wake up and breakfast is already prepared. Your clothes are already folded. The house is already cleaned. The robot is charging at its dock because it knows you'll be home late today. It checks on your grandparents in the next room and sends alerts if anything seems off. It notes that you usually drink water at 9 a.m. and prepares a glass for you. Not because you scheduled it, but because the robot has learned your habits, just like Tesla FSD learns from millions of miles of human driving. How can the Tesla Bot Gen 3's 22 degree of freedom hands play the piano? A fast-running robot is still not enough to enter the real working world. What truly determines whether a robot can replace humans lies in the hands. Musk is right. Hands are the hardest part. And that's not an exaggeration. The human hand is a mechanical miracle of nature, something robotics has failed to fully replicate for decades. But Tesla is getting extremely close. Close enough that many people felt chills watching Optimus fold clothes, pick up small objects, or perform delicate grasping tasks. Optimus 2.5 has a 22 degree of freedom hand system, a level almost unheard of in commercial robots. Each finger has 3 independently actuated joints, capable of rotating, bending, gripping thin objects, releasing items precisely, and even transferring objects between fingers with stunning accuracy. Its grip force control is incredibly smooth. It neither drops objects nor crushes them. This is where most current robots fail. Previous robotics demos typically stopped at grasping simple shapes, yet Optimus demonstrates human-like object handling, fast, precise, and stable, as if it truly has a sense of touch. So when Tesla says Optimus Gen 3 will be able to play the piano, it isn't a science show. It's the natural result of a 22 degree of freedom structure combined with millisecond-accurate torque control. Piano playing requires not only accuracy, but finesse, and independent control of each finger. The index finger must press firmly, the pinky softly, the thumb must rotate, all within a continuous rhythmic motion. A robot with low degree of freedom hands simply cannot press keys with the correct force direction, cannot glide quickly across the keyboard, and certainly cannot perform the well-known crossing hand movements used by human pianists. Optimus is different. Thanks to its finger-level dexterity, the robot can place each finger precisely on the edge of a key, press lightly without missing, and press hard without being heavy-handed. More importantly, its precise grip force control lets it feel the key's return force, similar to how humans adjust pressure while playing. Actions like spreading 2 fingers at once, rotating the wrist to change hand position, or moving quickly across chords all become possible. This is something many earlier humanoid robots, despite looking impressive, were completely incapable of. And remember, this is only Optimus 2.5. Gen 3, the version Tesla is quietly preparing for large-scale production, is even stronger, faster, and above all, optimized in hand structure to meet industrial standards. When a robot can fold clothes faster and more accurately than a human, manipulate thin objects like paper without tearing them, and hold an egg without breaking it, then playing the piano is simply the next step, fully within reach. Fine object manipulation is the true measure of whether a robot can work 100% like a human. A robot that can lift a 20-kilogram steel plate but can't pick up a small screw is still useless in a factory. A robot that can carry a box but can't hold a glass cup without breaking it still isn't ready for home life. Optimus is crossing that boundary. Tesla achieves this through its philosophy of learning from real humans. The neural networks that control the hands are trained on massive-scale human motion data, something no other robotics company currently possesses at this level. The robot doesn't just copy joint angles. It learns how humans apply force, how fingers adjust their trajectories when touching an object, how the wrist rotates to reduce torque. And once these simulations reach high enough fidelity, the robot can manipulate objects like a human hand. No more mechanical imitation behavior. When you watch Optimus pluck individual keys, perform a glissando, or play chords, one thing becomes clear. The 22-degree of freedom hand isn't just a technical specification. It's the gateway that allows robots to truly work like humans. From playing piano, to delicate industrial tasks, to caregiving support, everything starts with the hands. And Tesla now holds the most critical piece of the humanoid robot era. Why is Optimus Gen 3 the version Tesla chose to mass-produce millions of robots? Tesla never reveals its most important version too early. That's why the world has only seen Optimus 2.5, even though most internal engineers confirm that Gen 3 is nearly complete. Tesla's insane development pace, releasing a major upgrade every 6 months, suggests that Gen 3 will be stronger, faster, better balanced. Its hands more dexterous, its torque higher, its design more compact, lighter, and more refined, and above all, optimized for mass production at the scale of millions. This isn't a robot for demos. It was born to serve millions of customers around the world. This strategy mirrors the Model 3 in the EV industry, but this time the scale is far bigger. Because Tesla isn't just launching a new product, it is creating an entirely new industry, the first era of mass-produced humanoid robots in history. Optimus Gen 3 is the foundational building block. When you look at Tesla's philosophy of scaling optimization, from motors, materials, assembly lines, and logistics to AI, it becomes immediately clear why Gen 3 is the version Tesla intends to put on production lines by the millions. And Musk isn't joking when he talks about the plan to build 1 to 10 to 100 million robots per year. When he first said that, many people laughed. But now, look at the evidence. Fremont has already cleared a large area to install a production line capable of 1 million robots per year. Giga Texas is preparing space dedicated specifically for Optimus. Chinese supply chain partners have confirmed that Tesla is ordering robot components at an unprecedented scale, and Tesla is even hiring an actuator program manager in Vancouver, a clear sign that they are expanding a global supply chain for robot manufacturing. A humanoid robot is not a toy. It requires hundreds of small motors, precision actuators, a lightweight yet high-strength frame, real-time neural network control, cameras, sensors, and AI-driven fault correction. No other company besides Tesla has a supply chain optimized over 20 years to build something like this. Everything Tesla built for the EV industry has now become a decisive advantage as it steps into robotics. The same philosophy applies: vertical integration, in-house production of critical hardware, standardized mechanisms, cost reduction through scale, and AI replacing traditional software. If Optimus reaches a price of $20,000 to $30,000 when mass-produced, it will become the best-selling technology product in human history. Many people compare it to the iPhone, but in reality, that comparison doesn't make sense. A humanoid robot can work 8 to 12 hours a day on your behalf. Its economic value far exceeds that of any product ever created. A machine that can generate tens of thousands of dollars of labor value per year, never gets tired, never needs vacation, and never asks for a salary. But perhaps the strongest signal of Optimus's future doesn't come from demo videos. It comes from people, the brilliant minds flocking to Tesla. A prime example, Yilun Chen, a robotics engineer from Apple. He shared that the Optimus lab is larger than he expected. The team is far stronger and more resource-rich than he imagined, and Tesla's hardware-software AI stack is heading in the right direction. When an engineer at Apple, a company known for high benefits, stability, and low risk, decides to leave and join the Optimus team, that says a lot. No top engineer leaves a safe environment to join a dead-end project. They only choose places where they believe the future is being built, and they are choosing Optimus. That is the signal the tech world truly needs to pay attention to. When senior talent leaves Apple, Google, Boston Dynamics, and Meta AI to join Tesla Robotics, it means Optimus isn't just viable. It is becoming a convergence point for some of the brightest minds, something only era-defining products have ever achieved. Optimus Gen 3 is not a demo, not an experiment, not a concept. It is the first building block of an industry capable of producing tens of millions of robots per year. An industry Tesla is preparing for right now, laying the foundation, expanding the supply chain, and attracting top talent to make it real. That future is being built in Fremont, Texas, Vancouver, and Shanghai, and it is arriving faster than the world expects. So, as Tesla aims to produce millions of robots per year, what do you think will happen first? An economic boom or a large-scale labor crisis? Please share your opinion in the comments section below this video. Thanks for watching our video. Subscribe now so you don't miss the next breaking Tesla update. It's coming in just 2 days. If you want to explore more exciting information about Tesla EV or Tesla Bot, don't forget to hit the like button and share this video. Tesla just stunned the entire tech community by unexpectedly releasing a video of Optimus Gen 3 running at about 5.2 miles per hour, faster than what Elon Musk had previously suggested was the safe limit. In this update, the Tesla Optimus Bot doesn't just run. It even has a moment where it practically takes off, mimicking true running form, something very few humanoid robots in the world can achieve. Not stopping there, Tesla shocked audiences again with a robotic hand featuring 22 to 24 degrees of freedom, along with a neural simulation system capable of generating virtual environments that closely resemble the real world for robot training. Elon Musk has officially confirmed that this is the final demo of the Tesla Bot Gen 3, before the first commercial version is released next year. Welcome to Tesla Car World. Today we're going to explore what are the 5 latest updates to the Tesla Bot Gen 3 prior to its official release? And why is Elon Musk so confident that Tesla Optimus will become an even more valuable product than electric cars? First, let's go through the 5 most notable advancements coming to the Tesla Bot Gen 3, including its ability to run and control lower body movement far beyond expectations, an extremely complex robotic hand that closely approaches the structure of a human hand, and an advanced AI simulation platform that lets the robot train. Dr. Scott Walter recently pointed out something interesting. Most robot companies avoid sharing the real operating speed of their robots because they don't want direct comparisons. But Tesla is doing the opposite. They openly release raw, unedited videos, include clear speed calculations, and even let independent experts verify the footage frame by frame. This transparent approach makes Tesla stand out in the humanoid robot industry, where actual performance is often unclear. Later in today's episode, we'll also take a closer look at how Tesla is preparing to manufacture Optimus Gen 3, a crucial step before these robots can officially go on sale early next year. Because normally, if Tesla followed the same process it uses for its electric cars, pre-orders would have opened a long time ago. But so far, everything has stayed completely quiet. According to several signs, Tesla appears to be preparing to enter the mass production phase for Optimus. Sources from China and Canada report that Tesla will conduct quality inspections at its factories from December 7th to 13th. Giga Texas has already begun setting up dedicated facilities for Optimus. And at Fremont, there's even talk of a production line capable of building up to 1 million robots per year. These moves align perfectly with the roadmap Elon Musk previously announced. The Optimus Gen 3 is expected to be unveiled in the second quarter next year, and possibly as early as March. Since preparing a factory usually takes years, Tesla has no choice but to start this process now if they want to stay on schedule. Returning to the updates for the Tesla Bot Gen 3, previously Philip Piekniewski, an AI researcher, delivered one of the harshest early critiques of Tesla Optimus, calling the initial demonstrations embarrassingly unbelievable and describing the project as a complete scam. He argued that real-world drop tests were necessary to validate the robot's true capabilities. But today, he himself has finally seen convincing evidence that meets the very standard he demanded. The headline moment came from the running sequence. Optimus Gen 2.5 covered roughly 4 meters in 1.71 seconds, which independent calculations confirmed it as 2.34 meters per second, or 5.2 miles per hour. That number itself is impressive, but the more meaningful milestone is that Optimus exhibited a true running gait. The robot had a genuine flight phase, a few frames in which both feet were airborne. Only a handful of advanced bipedal platforms have ever demonstrated this, and even fewer have done so in stable, controlled indoor environments. This matters because most real-world labor tasks, factory transport, warehouse movement, home assistance, don't require robots to sprint. What they require is the ability to walk confidently, navigate around humans, and move quickly enough to remain useful in dynamic settings. For context, earlier iterations of Optimus topped out at 1 to 1.2 miles per hour, far below human walking speed. Hitting 2 to 3 miles per hour reliably was the minimum threshold for many jobs, and Tesla has now surpassed it by showing the hardware can comfortably reach much higher. The performance jump suggests Tesla's locomotion algorithms are rapidly improving, building on the company's deep experience with real-world AI from its autonomous driving program. Of course, the demonstration wasn't perfect. The toe section of the robot's foot visibly flexed upward, likely the result of a split-sole design. While intentional, it's a point that could trap debris in outdoor environments. Dr. Walter predicts Tesla will fully enclose the foot in Gen 3, a reasonable refinement as the robot approaches practical deployment. At a recent event, Tesla offered the most detailed look yet at its Gen 2.5 robotic hand. What the company revealed was far more sophisticated than a typical gripper and closer in spirit to a biomechanical replica of the human hand. The robot's hand is engineered with remarkable sophistication. It features 22 degrees of freedom, and up to 24 if you count the nearly imperceptible micro-movements. Inside, 17 linear actuators work in harmony to drive a system of tendons and artificial ligaments, producing movements that are surprisingly precise and lifelike. Wrapped around it is a flexible glove, specially designed to stretch exactly along the natural fold lines of each joint, allowing every motion to flow smoothly, much like a human hand. The tendon groups are color-coded by function, from flexion and extension to lateral movement, optimizing both force control and directional precision. The effect is a hand with a remarkably human-like structure, a thumb with a dedicated opposing joint, a pinky metacarpal capable of independent motion, and distributed tension systems that allow fine control without requiring a motor at every joint. The trade-off, however, is complexity. Tendon-driven systems must compensate for the fact that tendon length changes as the wrist rotates, producing unintended finger motion. Humans solve this naturally with neuromuscular coordination. Robots need algorithms. Tesla appears confident it can handle this through software, though it remains an engineering challenge across the robotics industry. Another issue identified: when the fingers open fully, a large gap appears along the top knuckles, stretching the glove. Over time, this could lead to tearing. He predicts Tesla will tighten this design in Gen 3 and potentially add more actuators for a fully active extension system rather than relying on passive tension. Still, the current design represents a major stride forward in dexterity, one of the hardest problems in robotics. Running is impressive, but the ability to handle tools, fold laundry, operate machinery, and manipulate everyday objects is what will ultimately define a humanoid robot's usefulness. Perhaps the most forward-looking reveal came from Tesla's neural simulation environment. Unlike traditional game engines, this simulation runs entirely on neural networks trained from billions of real-world images collected from Tesla's fleet. The result is a dynamically rendered environment with realistic lighting, physics, and textures, generated in real time by AI. A demo showed participants driving a car using a steering wheel and pedals while a neural model produced every frame. If the system works for vehicles, it could work even better for robots. Tesla's plan is clear. Train Optimus inside a virtual world that mirrors reality so closely that the robot can practice skills, tasks, and edge cases without risking hardware wear or safety issues. This is the same strategy that accelerated Tesla's full self-driving progress, but applied to humanoid AI, it may prove even more transformative. Recently, reports from Chinese suppliers suggest Tesla has already begun quality testing at multiple factories. Giga Texas is preparing space for an Optimus production line, and Fremont has a referenced capacity of up to 1 million robots per year. While timelines in robotics often slip, the implications are clear. Tesla believes the hardware is close enough to justify industrial-scale planning. Meanwhile, Elon Musk says Optimus Gen 3 will be revealed in the second quarter of next year, likely March. Dr. Walter expects incremental refinements, not a complete redesign, including more motors in the forearm, improved thumb stability, and a fully enclosed foot. Gen 2.5, in his view, is the testbed that lets Tesla's software team train at full speed, while hardware engineers finalize the next generation like Gen 3, 4, and 5. When will Tesla Bot Gen 3 go on sale? How many units and price? Optimus Gen 3 is approaching release next year with a complete redesign, and everything we're seeing makes it clear that Tesla is accelerating the project faster than anyone expected. Unlike Tesla's history with electric vehicle delays, every update related to the humanoid robot is moving at an unexpectedly rapid pace. Elon Musk has already stated that Optimus will begin performing real tasks in Tesla factories before the end of the year, with external sales expected in 2026, and we already know that around 50 units are quietly working inside Tesla's manufacturing lines. By next year, Tesla expects to have over 1,000, possibly several thousand bots internally. The transition from Gen 2 to the premium Gen 3 model marks a critical leap. A new aesthetic, a significantly upgraded hand with 22 degrees of freedom, faster locomotion, and a smarter, more autonomous AI brain. Yet the real bottleneck Musk openly acknowledged is not capability, but manufacturability. Designing a humanoid robot with few enough parts, simple enough tooling, and a resilient supply chain to produce it at scale. Musk himself said redesigning Optimus for mass adoption is the hardest part. For a product this complex, the design must satisfy usability, structural strength, long-term reliability, and cost efficiency. The Cybertruck already proved how a bold design can cause manufacturing headaches, so Tesla clearly invested enormous research effort into making Gen 3 manufacturable. This is also why the idea of a $20,000 price tag is increasingly unlikely. A $100,000 price point is more realistic in the early years. Meanwhile, the stronger political connection between Elon Musk and Donald Trump since Trump's return to office could open unexpected policy support for robotics development. While jokes about Trump using an Optimus as a bodyguard are clearly not serious, the broader point stands. Optimus still has a long way to go before becoming a fully capable homemaker or personal assistant, but the trajectory is unmistakable. Musk claims Optimus will eventually teach children, babysit, walk dogs, mow lawns, get groceries, and serve drinks. Anything you can think of. It sounds exciting, yet most people remain skeptical. Can robots be trusted around kids? Will they ever be safe enough for homes, schools, and nursing facilities? Despite dystopian movie tropes like Terminator or I, Robot, Musk insists Optimus will be closer to C-3PO plus R2-D2, a helpful companion, not an existential threat. Today, Optimus operates at roughly one-third of its potential. Yes, it can perform various tasks, but these remain basic, and customers paying $20,000 to $30,000 expect much more. People want a robot that truly helps, preparing meals, safely watching children, reminding elderly family members to take medication, using appliances, cleaning thoroughly, and performing real household work. Without such capabilities, it risks becoming a novelty instead of a necessity. Tesla's newest videos showcase Optimus performing more real-world tasks: watering plants, cleaning kitchens, picking up delivery packages, loading and unloading items from car trunks, and transporting objects around the home. Tesla positions Optimus as a safe, friendly household companion capable of natural conversation, able to chat with seniors, answer children's questions, and provide day-to-day company. But safety is the real concern. How does Optimus prevent cross-contamination when switching tasks? Like taking out trash, then preparing food? Humans wash their hands. Can a robot do the same? That problem is actually solvable thanks to Tesla's incredible hand design. The hands are tendon-driven like human hands, have fewer water-vulnerable components, use materials that clean easily, and may even incorporate antibacterial surfaces. Musk confirmed that designing the hands alone consumed half of the total engineering effort for the entire robot. And these hands matter because a humanoid robot would be useless if owners had to program every motion manually. Instead, Tesla uses imitation learning, Show Optimus a task, and it learns the behavior. Musk said Optimus can watch a video of a human performing a task and then reproduce it, which bypasses the need for enormous pre-programmed datasets. Optimus can also interpret body language, recognizing pointing gestures, directional cues, and intent, allowing intuitive communication even for those who struggle with verbal speech. This marks a radical shift. Robots are finally becoming practical in the real world. Tesla's strength in real-world AI, built through years of autonomous driving development, gives Optimus a neural brain no competitor has. Just as Tesla trained its cars to navigate the world using cameras and neural nets, the same architecture now translates into a robot capable of walking, manipulating objects, sensing people, and adapting behavior autonomously. Musk openly states Tesla is the leader in real-world AI, and Optimus is where that advantage becomes undeniable. And now, the manufacturing plan for 2025 reveals the next phase. Elon Musk confirmed Tesla will deploy at least 1,000 humanoid robots internally next year, marking the first true large-scale industrial use of Optimus. He has long envisioned the machine that builds the machine, and Optimus is the missing link. Current factory robots are powerful, but fixed in place and limited to single-purpose tasks. To fully automate manufacturing, mobile general-purpose robots are necessary, and that's exactly what Optimus provides. In the latest demo, Optimus navigated through a bustling workspace full of machines and workers, autonomously mapping new environments without pre-programmed routes. This behavior mirrors how humans navigate unfamiliar places, except Optimus instantly builds and stores a complete 3D map, making it even more efficient over time. And the timing is no coincidence. Manufacturing suffers a labor shortage of 300,000 workers in the U.S., with logistics short 600,000 to 700,000 more. The world will need robots. AI breakthroughs of the past few years have made it possible. Musk predicts Optimus could push Tesla's valuation to $25 trillion, and that demand could reach 10 to 20 billion units globally. Investors agree. Humanoid robotics is projected to become a $38 billion market by 2035, and new robotics startups are emerging monthly around the world. Yet Tesla's biggest advantage isn't AI alone, it's scale. Every major component of Optimus is Tesla designed. Actuators, motors, electronics, batteries, and structural hardware. This vertical integration allows faster iteration, lower cost, and mass production unmatched by competitors. Musk says production cost per unit could be as low as $10,000 over time, enabling a future where Optimus becomes as common as cars. Tesla plans mass production starting 2026, with early consumer versions priced at $20,000 to $30,000 and dropping later. Before that, Tesla will offer a rental model, about $200 per month, to test real-world deployment while keeping tight control over safety, maintenance, and usage. Since AI autonomy brings inherent risks, Tesla must regulate how Optimus is used before millions of units reach homes. This rental strategy allows controlled scaling, safe field testing, and constant data collection. Ultimately, Musk's long-term vision is clear: a world where every home, every workplace, and every individual has access to a humanoid robot that performs dangerous, repetitive, or time-consuming tasks, enabling a future of unprecedented productivity. Optimus could handle child care, elderly care, education, cooking, household chores, pet care, yard work, shopping, and companionship. Factories could eventually be staffed primarily by robots that build the next generation of robots. With Gen 3 launching in December, faster improvements each quarter, and AI accelerating exponentially, the world is rapidly moving toward a future where general-purpose humanoids are mainstream. The only remaining question is not if Optimus will scale, but how fast Tesla can bring billions of these machines into reality. Before Tesla makes Optimus widely available for purchase, Musk has stated that the company will first roll out a rental program. This approach lets customers experience the robot firsthand, while giving Tesla access to valuable real-world performance data. Current expectations suggest the rental fee could be around $200 per month, making early access far more attainable for most people. This strategy allows Tesla to evaluate how Optimus behaves across diverse environments while keeping tighter control over user interactions. Because Optimus is a highly capable AI-driven machine, its behavior is more complex and potentially more challenging to manage than many assume. Even with extensive safeguards, autonomous systems always carry some level of risk. So, should highly autonomous robots like Optimus be released to the public at all, or is the safety risk still too high? Please share your opinion in the comments section below this video. Thanks for watching our video. Subscribe now so you don't miss the next breaking Tesla update. It's coming in just 2 days. If you want to explore more exciting information about Tesla EV or Tesla Bot, don't forget to hit the like button and share this video. Also, make sure to turn on notifications so you never miss our latest videos. We appreciate your support and look forward to seeing you in the next video. Goodbye.